graph of simple harmonic motion, acceleration time graph. So first kita buat displacement for x equals to a sin omega t. Then for velocity we got a omega cos omega t. Okay, so for acceleration is dv over dt. We're going to differentiate the velocity equation. All this thing is with the condition that when t is equal to 0 second, displacement is 0 meter. Okay, when we differentiate a omega cos omega t, we got negative a omega sin omega t. Okay, when we got this condition means that our phi is equal to 0 radian. Okay, so acceleration equation is a negative a omega sin omega t. First we look at the axis first. So y axis is acceleration, ms negative 2, x axis is time, second, then a maximum, then we got a label maximum acceleration, negative a, is omega square. Okay, because at the term at the back when maximum value is equal to 1. Okay, so it's negative a omega square, then we have positive a omega square. So bila kita draw, you gotta make sure that you punya top here tak lebih daripada a omega square, and your bottom part here pun tak boleh lebih daripada a omega square. And also you have to make sure that dia punya size tu lebih kurang sama, tak boleh satu kecil satu besar. Okay, then because it's negative means that kita kena terbalikkan graph sign. Kalau graph sign yang biasa is like this. Okay, bila it's negative means that it's going to be upside down. We're going to start with negative, we go down and we go top. And also as I said, mestilah lebih daripada 1 full cycle. Paling sikit is 1.5 lah, macam yang saya buat. Okay, so from the graph, sama juga, you gotta know that the value for period and also a omega square. If you are given all the value, means that you can label all the value as well. Okay, that is acceleration time graph. The next graph is energy and displacement graph. So energy and displacement graph, first kali kena label dekat atas ni, energy the unit is joule, x the unit is displacement the unit is meter, then as amplitude is negative amplitude, then kita ada graph senyum and graph masam. Okay, first you kena buat putus-putus ni, putus-putus dekat A, putus-putus dekat negative A, means that your value cannot exceed for value A and cannot value negative A. Tu maksimum lah. And also kalau tak, saya buat kat atas ni juga. Ini adalah total energy. Okay, then graph masam ni yang the blue one is kinetic energy, graph senyum is potential energy. So we know that bila kita ada pendulum, okay, kita ada pendulum ni dia swing, this is negative A, yang ni equilibrium lah. Okay, bila x equal to kosong, first dia akan maximum kinetic energy. Kinetic energy akan banyak dekat sini. Sekejap. Oh tak, ni potential energy, sorry. Potential energy akan banyak dekat negative amplitude. Dan bila dekat at the bottom here ada equilibrium, means that all the energy, all the potential energy dah tukar kepada kinetic energy. Right? Mula-mula dekat amplitude kita ada banyak potential energy. Then dekat equilibrium, all this potential energy is converted into kinetic energy. Then we go back to here, we swing to the maximum amplitude balik. All the energy semua dah converted into potential energy. Kenapa tak ada heat energy, sound energy or other type of energy? Because with the assumptions that for simple harmonic motion, we assume that there is no energy loss. Means that energy tu akan main antara kinetic dan potential sahaja. Okay, so untuk potential equation for E ni, apa equation E? So E, potential E adalah half Ka square. Okay, ataupun K ni adalah half M omega square A square. Then potential energy ni equation dia apa? Half Kx square. Okay, yang ini adalah half, saya tak ingat lah, half M omega square A square minus X square. Means that potential energy dan juga kinetic energy ni bergantung dengan position. It's not the same at all position. So kena masukkan lah kinetic energy ni berapa value amplitude. So from the graph, awak kena tahu baca energy, total energy and also the amplitude as well. Okay, and lastly is 9.3 is about period of oscillation. So kita ada dua period, awak tak jangan confuse So kita ada for spring and also simple pendulum. Macam mana kita nak tahu tu spring? Kita ada K. K is a spring constant. So mass ni adalah mass lah. Unit dia mestilah kg kita kena guna SI unit. Then for simple pendulum kita ada L is the length, K unit dia meter, dan G ni adalah gravitational acceleration lah, 9.81 ms -2. Okay, so period ni unit dia adalah second. Period ni apa? Is the time taken for one full complete oscillation. So by the bottom here is the changes happen to your period of oscillation. Kalau kita add mass, kita tambah mass, what happen? Smaller k, what happen? Longer L, what going to happen? So if we add mass, we're using smaller k and using longer pendulum, longer string for the pendulum, our period of oscillation going to increase. So this one, soalan ni selalunya datang bahagian last kali untuk menentukan awak dapat A 90, awak dapat 99 ke awak dapat 100. Ni adalah soalan kebat lah. Okay, so that's it. Remember, kalau smaller k means that dia easily easily move kot. Bukan, not sure lah what's the word. Kalau greater k, bigger k means that it's stiffer, keras. So kalau dia smaller k, dia lagi lembut, lagi senang dia nak bergerak upside down, up and down. Okay, that's it. Thank you.